Guys, how you going? I will try and do this as quick as I can. I wasn't going to do this, but I figured we're so close to the bottom, I might as well just strip out the rotor so you can see how that happens, and then you should be able to, because when you build it, if you want to build this, you build the motor first, you put your top on, which we're going to do. We're going to reassemble it. The top goes on, you can run that as a motor, get it running, then you take the top off, put on the next stage. Right, so here we go. I'll speed this up here and there so it doesn't bore you too much. I've used a little plug. I should have tried to get a smaller plug than this one. It's something that clicks together a bit easier. You could use like a phone connection plug or an Ethernet connection. Something just clicks in. And all that plug does is drives my, which I'll pull out in a second. So now that it's out of the road, it's the only thing. These just slide out, like I said. Ooh. Oh no. Slide out too much, but they slide out. Oh, that one. And I just put a bit of extra length in the wires so they could slide out and allow me to get at my rotor, because you might have to pull this in and out 10 times. And you can see at the bottom here we have our timing light sensor. So that's just got 4 sides on it. We've got our magnets up here. I should have really glued all these in a bit better, but anyway. So they're short screws for these little ones because they're touching the ones on the other side, and I had to sort of drill them in on a funny angle so that you'll see it when you go to do it. These ones are alright, the screws almost come through the bottom here and almost through the top. That comes in 2 parts, and then you put a lid on the top, so you can have 3 stages. I did it so you can just stack them up. Boom, 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 boom. You can have stack up 4 stages. You could put 8, you could redesign this and have 8. I've done it with 8, but it means it's going to fire 8 times to go 1 revolution. This way it is, so higher speed, less torque this way, double the torque, halve the speed the other way. Well, it's sitting there because the rod's sticking out the bottom. So there's a little cap in there, that's where your little cap goes. This is it. So we've got it. We've got 2 different positions. You can't have one here and one here. They had to be, but trust me, they're out of time with each other. So it's just a light sensitive resistor in there. We've got a LED light here. So we've got power in to run the lights and to run the resistors. And then these 2 yellow ones are signal out. That's it. So that's all in there. That goes in here, and you can turn it to change the timing. So that just slides, that goes in there. And that'll just sit there. This little cap here, there's a little cap. Oh, a little cap. And that, when you screw it down, that'll push down on that and stop it from, it'll tighten it up, so you have to turn it, you might have to back it off a bit. So I just screw, that's threaded. The plastic in there has got I've used a thread, I've cut a thread in it, and then this screws in and tightens up. And that's it. So pop that back in. Right, I'm back. It was just the earth had dropped off. I'll show you. What I've done is I do everything on the earth side, so because it's electrons we're dealing with anyway. So everything is positively, like the positive side runs through the coils to the switch on the earth side, and then I just switch the earth. So I only ever switch the earth, I don't switch the positive side, I switch the negative side. So I bring the positive all the way through, and then the earth waiting to connect, and it seemed the switches run colder, Yeah. they just got a bit loose. That earth, so the earth runs in here. It just got a bit loose and fell off. It's too big of a bulky switch, this one, but you know, that's what I had to go with. Anyway, that's that. Circuit breaker, so down here the power comes in. Diode, so you can't reverse the polarity. Circuit breaker into the amp meter. The positive runs through and starts charging everything up. Anyway, it's the earth that I use as the switch. So when you're switching here to turn your power on, it's the earth you're turning on. You know, bang, I've just connected the earth. But that's how I do everything. I don't do it on the positive side. Seems stupid, doesn't it? Because they refuse to believe that the electron has an opposite, and you know, they only believe in the electron, yet they're always switching the positive. They're not switching, you know, weirdos. So you need more than, because of the diodes and this and that, the switches, I had to put resistors on the transistors so they don't burn out, don't draw too much current, and you know, it's only good for a certain voltage between, I think it drops off after below 9 volts. I'm not sure what the top end is. It'll probably go 16 volts or something. But anyway, there it is. And what you can do is you can get in here and you can turn that thing. Well, it's slowed down. You can have an oscilloscope going, and you can see where it runs best. All I do to tune it is I go back and forth a few times and find out where it wants to, where it's running quite well, you know. Is there a bearing in there? Yeah, there should be a bearing, yeah. Looks a bit wobbly, doesn't it? Naturally, the lower you bring this down, the better it'll be. So there it is, we're getting 58 hertz. And if we turn a bit, it's dropped off, so I'll turn it the other way. And it's dropped off. So we come back this way a bit. And it's picked up. And it's dropped off again. So I'd use an oscilloscope to tune that. I think it's about there anyway. I can hear it. It wants to run better here. And that's all I'm doing. I'm just pushing, I'm turning that, and it's just changing, and you can back it off a bit here. So now I've turned it down. We're only at 11.5 volts, we're not even 13 or 14 volts. As we're back into it, I have gone out and got the discs to put in, and here they are here. Like I said, I'm not happy with them, and this might be a total waste of my time, and I might have to redo this whole exercise. When I 3D printed that, when I did them, I made it 0.5 mil lower in here, so it could be filled up with a resin. I just think I should have painted it anyway. So here we have it. This is the thing that I was talking about. This isn't 3D printed, it's a bit of electrical conduit from the shop. It is 27 millimeters outside diameter. So what I did was I took this part, this is the part that joins them, and it goes on there, falls into that keyway. And a bearing goes on it. So I printed this, I put it in the lathe, I machined out the bearing, I had it on glass. I printed this on glass so that this side here is perfectly flat. Right, bang, you're at 90 degrees. So you put hard up in the chuck, machine it, nice tight fit on the bearing. Then I had to flip it, and this, you know, this is where you might get a bit out. I've tried to pencil mark, so I grabbed in the same place, and then just a 3-jaw chuck, and then machined out the inner side. You know, anyway, it's nice tight fit. That's it there. The length of this thing, because you'll have to cut it to length. The length isn't written anywhere. The length of this thing is 17.5 centimeters. It could be a little bit longer, I think. I think it could be 18 or 18. It could be a little bit longer. There's room in here to put it in or pull it up or whatever. Again, because the velocity is, it's just spinning, up-down movement, doesn't matter. There's no up-down movement on these things. Anyway, I've lost my bearing. So here we go. So we take our main other bearings in the bottom. We take our, I marked this one. It's a nice tight fit. The bearing on the top's a bit loose. I've marked this one. And this is why you have to turn it, because obviously, as you turn this thing, the one on top here, they're never going to be exactly right. When you think about it, you can never get it right. It'll always be half a few thou out this way or that way. So this way you can just keep turning it until you find the best one. It's a way of tuning it, or balancing it. We've got that on there. There we go. And now all we're going to do is we're going to pick our first disc, and it's going to, I use a glass bed, so the bottom of it's been painted on done on glass. The top of it, I've sanded it off as best I could. I think I put it on a flat surface and rubbed it, and it just made sure it was flat. But I've put alfoil and all that on there, so it's going to change. Line up my little holes a bit. What did I say, 175? It could have been an extra, it could have been 180. 185, an extra 10 mil probably wouldn't hurt. I can measure it and tell you, righto, so that's about half, or a bit more. And again, these are printed on a glass plate. So I've allowed extra, I think it's 5 mil on each side, so it doesn't, you got a bit to play with. It doesn't have to be exact, but you want it nice and straight, so you want all of them to be nice and straight. Come around this side, you want them to be nice and straight. This one to be nice and straight. And then that one at the top to be nice and straight. Now we've got to balance it. I will get the, you need the rod here sitting in front of you. I'll go and get one, I'll come straight back. Righto guys, here you go. Here it is here, I've gone and got the shaft. And what you want to do is just turn it a bit, let it go, and just see what it wants to do. You wouldn't want it to move real fast. It's moving quite a bit fast there. So what I'm going to do is, I'm going to pull out this chopstick. Both of the chopsticks are going to come out. And I'm going to turn it. And I'm going to turn half of it one way and put chopstick back in. And balance it again to see if it rocks again. So that's what I'm going to do. I'll do that now. And it's pretty close, but it, you know, if you're running high, if you want to run a few revs, you might as well take the time, try and balance it as best you can. If it's not good, I'm going to come back to this position. So I'm not going to, you know, I'm just going to turn it and then see if that's an improvement. If that's an improvement, well, that's great. Look, that's not too bad. I'll turn down a half a turn. Let's come back a bit. We'll go a half a turn again, the same way. So that is. And that's not too bad. It's a lot better. So I'm just going to go with that. That's pretty close to me. It's not got that big dip in it. So all I'm going to do now is go through, line these up again. So I'm going to turn that one there can come forward, that one can go. Righto guys, now I remember what I did. I used a sharp pointy skewer to line them up, and it made it a bit easier. I don't know why it won't line up. This one, I guess, doesn't like the idea too much. There it goes. No reactive force on this disc. There's nothing to touch it. It's not dragging or touching anything. Nothing can really put it out of time. Again, out of balance or anything. And that looks pretty good, doesn't it? It's got a little bit of a heavy spot there, but it's not too bad. Yeah, it's just kind of a gentle stop. And didn't really roll backwards much. Look, it's rolling backwards a little bit. That's about it. Alright, so that's fine. I'm going to go with that. So, all we do now is we pop that back on. The marks just line up straight away. Whether it's going to be in the same deal or not, I don't know. But obviously, like I said, these four shapes, this four-sided shape, gives you four options of putting it together. I could have done an 8-sided shape, I guess, as well. The big thing we're looking for is we want these discs to be running quite smooth, quite flat, without a lot of vibration. Up and down vibration, because we want to go in like that. And they all look pretty good. And it seems to fit in. If it was wobbling, I'd lift it up, I'd turn it a quarter of a turn and put it down. I'd turn it clockwise a quarter of a turn. And then I'd pick it up, turn it clockwise, put it down. Pick it up, turn it, put it down. But I'm pretty happy with that. Well, I've got to give it too much power. Probably choking it out a bit. It likes to run wherever it likes to run, you know. Alright, the top one's a real bad wobble. So we can sort him out later on. And he's the he's in there, and all I do with him is I should have made a better effort at setting that, given it a surface. Maybe even have kept it on this cylinder. The reason why I just want to keep the cylinder's just a bit of electrical conduit. The longer it is, the more chance there is of it having a defect or being out of shape. So I just sort of keep it as short as possible. But next time I probably would I'd probably put them all on the shaft so that they're all, and maybe even turn down a plug and put it inside. I don't know, it's another thing. Anyway, that's that. Right, I would just wobble this. So all I do, I'll tip the camera up a little bit so you can see it. The top one here, I've made it so there's screws in it, and all you do is when you run it and you put your finger on it, there's a high spot, so you just pull that side down. And then I think it was just back there, pull that down. And you want it to stop on a high point. I think it was here. Yeah, that's the only problem with this motor. You can't just let it sit there like that because it'll be switched on. I use a circuit breaker, so if it goes over, starts drawing more than, I think this is 5 amp circuit breaker. If it draws more than 5 amps, the circuit breaker. But yeah, these motors, that's the only downside to them. Unless you can build a starter system, but you have to hand start them, and you can't just stop it. If I stopped it, the current, look, it's drawing nearly half a amp. So you can't have that. So you're going to start it, and away we go. I can bring that down a bit more. And by bringing it down, it'll help run it a bit smoother too. But the top's still a bit bumpy, but we'll sort that out later on. And that looks pretty good to me. Oh, give it a bit more. Let's put the battery charger on it, and it's a pulsing repair thing for the battery, so you might see how many revs we get. So that's not bad. That's doing 60 odd RPM. So that's 60 hertz. So it's divided by 4 times. I think it's like 12 times a second or something. Anyway. See that? I'll put a mark there. Now I'm going to lift it up. Righto, so I just adjusted it a bit. What I've done is I've brought one nut up on this side and one nut up on that side and got it looking about right, and now I've got a tray holding the top one. I just want to lift it up a bit, so I'm just going to get something. I want to lift it up maybe that much. There we go. So now I'm just going to take my tray, and I've pulled it out wide. I'm just going to take that, should just slide in now. Oh, it's still tight, isn't it? Oh, hang on. Start up the top. That one went in easy. As I come down, it'll tighten up, so I can just pull it out a bit more. And what I might do is pull it out. Let's see if I get that one to hold it in place. And the top one will fall down. What do you do? Anyway, we'll work. Oh yeah, so what I could do is put that one in place and use a smaller piece to lift it with, something like this. That one's in place, and now I use that to lift it. And now I can open it up to that width. Let's use this one to prop it open. Oh, there we go. Now we're nice and wide and open. Right. Ooh. I'm pretty happy with that, I think. So we can just check it. And there we go. It's running, you know, good enough for playing. Good enough for a 3D printer, you know. If you know, you could always make another one, a bigger one, and balance it out better and do whatever you like. Put on a single shaft. But anyway, that's good enough for our purposes, and we just hopefully we get a bit better voltage out of that disc. It's too loose. That measurement is too loose. That is 140, 45, 6, 7, 48. So it should be 149. Anyway, it doesn't matter, it goes in easy, so that's alright. Maybe that is okay. Righto, that's it. Yeah, that all goes back together and we're in business. I'll just hang on. Guys, it's the next day. I got sidetracked yesterday and had to go and do something else. So we're putting it all back together. To do the wires, I've already done, I forgot to record it, I've already done the other wires. So all I'm doing is taking 2 of these wires, or 3, I did 3, these ones, I take them, I give them, join them together, and give them a little twist, little twist to get them together, and then pop them in the hole. Take these two, join them together, give them a little twist. Pop them in the hole. Oh, pull right through. Righto, now what I've done, I wasn't sure what to do in the beginning. I was going to have one on this side and one on that side, and then I thought, oh, for testing and all that, better off just have everything on one side so I can work with it. So what I've got here is, I've got a wire in the top of that one, and I'm taking it around this side. So this corner has to go to its opposing corner. It has to come around here, and it shoves in. I've got it shoving in here. Give it a twist, poke it through the hole. It's a tight fit. It's okay for it to touch these ones, but you wouldn't want it touching that one. It's got to sit up so it doesn't touch the wires, because it'll break down through the wires. Where to here. So what you're going to do is shove them through a little bit longer and sort of bend them down with your finger so that they're all bent down. All in there, all bent down. And you take your cover cap, and there's a little notch in the top. And I actually filed off the back of it to get it to curve in a bit better. So you just pop that up. There's a wire, so this stuff's touching the aluminium there, and then there's a oops, this is touching that aluminium. There's a wire here. I've put a little wire there that runs through and touches inside the rod here, and it can go back and forth, and a little groove there for that wire. So it goes in there, you push him in, and then just screw him in. I think that's a 6G there that I used. Same deal on the other side. Where'd I put it? Here it is. I'll bring it over closer. I have got my butyl rubber, and I can push that rubber in, and then I've put a wire in with it. Oops. So I can push that rubber in or pull it out and adjust it. I've got a wire here coming to the top of the ring. So here's the neutralizer ring, and you can see which way it should go in the back here. There's little grooves to allow for that. So when it goes in, that'll screw, oh, you can't see it. That will screw on there, on the top of it, 2 holes. This wire will sit here, it just sits there on top of that. You could sticky tape it on if you want to. I should make a little block that sits on top, and you screw it down and holds it tight when you get it all in place. And then you can just pull it in and out a bit here. Oh. So that ring has got aluminium foil here. It's got a wire running around there. And I've used aluminium foil to cover the wire. So I put the wire on top of the first piece of aluminium foil, then put another piece of sticky aluminium foil over the top. And just stops it from, But now you've got a neutral point, and I'm not sure whether I should neutralize the whole body or keep it separate or what to do. Right, so that's that. And that's a neutral point. It's not really an earth, but it's a neutral point. Neutralizer. So that's that. All I've done here, I've kept the collector brush, or collector comb, whatever you want to call it. I've kept it as a wire, because I need a wire. And also, I got 2 pieces of wire, and this one I've just doubled it over, and now it's like a key. I've got something, and I twisted them all together and shoved them in the hole. They've tightened up in the hole, and I've got something I can twist and pull and push and get it to just touch the edge of the disc. Once you get charge going, it's going to jump the gap anyway, so it doesn't matter. And the other thing is, I don't want this Holtz machine to make too much power. Its job's just to top up and keep the charge in the rotor without overcharging it. So if I made this really efficient, it'd overcharge the rotor constantly. We don't want that. We want it to find a nice neutral spot and a bleed off, so we can bleed off charge. And I was thinking of some way of sort of, basically you got to bleed off the charge off the rotor. So it's all about the rotor, whether the rotor's overcharged or undercharged. I need to be able to bleed that off. So I need some sort of a flat surface and a pin where I can, when the charge builds up too much, it'll start to draw the charge off to air and balance itself out or stop itself from overcharging. So that's just going to slide in there. I can adjust my contact wire in and out. That wire is bent up. So I've just got it sort of pointing in, and the charges will spray off the end. And with the Faraday effect, the charges will charge up but not discharge. So here's the ring. We're just going to pop the top. Put our ring on. And I've got to level up that top disc. That's not bad. Righto, we're back into it. I'm having trouble with me battery now, of all things. Anyway, we're back into it. I forgot to put the bridging spark there. So there we go. And yeah, the sparks are looking a lot cleaner, for sure. And as I'll get the battery sorted out, and we'll get some speed going on it, but that's looking far superior. And we'll get some more. As the charge builds up in there, it's just going to do it more, isn't it? I hope it's not. It must be leaking in there, is it? It's going to rain today, so that might be causing a few problems as well. So here we go. I've increased the revs, so it's running with 19 volts now, and 93 times a second this is charging and discharging. So that's pretty good. We've got much better insulation. But we've still got a spark breakdown in the rotor down the bottom there. So anyway, it's all pretty good. It's just going to run now by the look of it. And it's an overcast day too, so that'll makes it hard for the Holtz machine to charge her up.